class is for class 9th and we are doing chapter circles and we are doing exercise 15.1 and we are following the book Understanding ICC Mathematics by M.L. Agarwal. Now in the previous class we have already done up to question number 19. Now we move on to the question number 20. This is also based on the diagram that is given. So I'll read out the question. In the given figure below AD is the diameter. So AD I have drawn as a diameter and this is a circle with center O. Then they say with center O is AB is parallel to CD. It is given that AB is parallel to CD and you have to prove that AB is equal to CD. In order to prove, now you can see AB and CD are two chords. Now in order to prove that two chords are equal, we need to prove that their distance from the center is equal. So to mark the distance, we have to draw the perpendicular from point O on chord AB and on chord CD. So our next point will be construction. What is the construction in this? Draw OM perpendicular to AB and ON perpendicular to CD. From O I am drawing a perpendicular M on AB and from this I am drawing a perpendicular ON perpendicular to CD. Now what we will do, we have to prove that OM is equal to ON. In order to prove ON and OM equal, we will consider these two triangles first and triangle 2. So we can say that in triangle OAM and triangle ODN, OAM and ODN. First of all, we can say that these two angles are equal because they are vertically opposite angles. Angle NOD is equal to angle MOA because these are vertically opposite angles. Second point, we can say that, or no need to say this, we will not say that these two angles are equal because it is possible, it is also possible that they are not equal. So we can say this angle is 90 degree as well as this angle is 90 degree. So first point will be angle OND is equal to angle OND is equal to angle OMA. OMA is equal to 90 degree and that is we have constructed. So I am writing construction. Second point is this side and this side both are equal. Why they are equal? Because OA and OD are, we can say OA is equal to OD and both of them are the radius of the same circle, so they will be equal. And then we can say that, and third point we can say that it is given that AB is parallel to CD. So if AB and CD are parallel, it means this angle and this angle will act as alternate interior angle. So we can say angle NDO is equal to angle MAO because they are alternate interior angles. Now we can say because of angle side and angle side, these triangles are congruent. This side and this side is also equal. So we can say that triangle OAM is congruent to triangle ODN. Now if the angles, if by which rule? By angle side rule, by AAS rule. Now when the triangles are congruent, then we can say ON is equal to OM or OM is equal to ON. So we can say that OM is equal to ON. By what reason? CP, CT. Now when these distances are equal, therefore we can say, because these are the distances from the center on the chord and these distances are equal, so we can say that chord AB is equal to chord CD. That is your proof. Hence proved. Now we move on to the second part of this question. Now in the 20th question B part, this is again based on the diagram. They say that in the figure given below, AB and CD are two equal chords. AB, this is AB, and CD, CD. These are two equal chords. So I have written AB is equal to CD, that is given, they are equal. Then they say are equal chords with center O. So the center of the circle is O and they meet outside at point T. They meet at the point E, which is outside the circle. We have to prove AE is equal to CE, first part. Second, we have to prove that BE is equal to DE. So what we'll do? Construction. First of all, we have to join something. First thing, if AB and CD are equal chords, then their distance from the center will be equal according to the theorem. So what we'll do, we draw a perpendicular from O to AB. Let us name it as M, and from this we can draw a perpendicular, let us name it as N. Now M and N are the perpendiculars and they will be equal because these are the distance of two equal chords from the center. So construction is draw OM perpendicular to AB and ON perpendicular to CD. Now one more thing we have to do, we need two triangles. So what we are going to do, join OE. We will join O to E. This OE we will join. Now we have these two triangles. Which one? Now we can say in triangle MOE and triangle NOE. We have two triangles MOE and NOE. In these triangles, since we have drawn perpendiculars, so this angle is 90, at the same time this angle is 90. OM is equal to ON because they are the distance from the center of two equal chords. And third thing, we can say that OE is common. What we can say, in triangle MOE and NOE, we can say first point is MO equal to NO because these are distance of equal chords from center, and we know that two equal chords are always equal from the center. So MO and NO are equal. Second thing, angle OME is equal to angle ONE is equal to 90 degree. Why? Because of construction. We have drawn perpendicular. Draw ON perpendicular and ON perpendicular. So this is 90, this is 90. Then we can say OE is equal to OE. Why? Because this is a common side of both the triangles. So we can say that triangle, let us say triangle 1 and triangle 2 are congruent by right angle hypotenuse side, right angle hypotenuse side. So we can say triangle MOE is congruent to triangle NOE by which rule? RHS rule. Now if the triangles are congruent, it means NE and ME are equal. Implies that NE is equal to ME, that is CPCT. Now this is what we will be using it to prove first and second part. Now we know that AB and CD are equal. It is given that AB is equal to CD. So half of AB will also be equal to half of CD, and half of AB can be considered as AM, and half of CD can be considered as CN. Now AM is equal to CN, and here we have proved that NE is equal to ME. NE is equal to ME, and here we are saying AM is equal to CN. Means it is given that NE is equal to ME. This is equation number 1. And it is given that CN is equal to AM. This is equation number 2. If we add both these equations, means adding 1 and 2, what we can get? NE plus CN is equal to ME plus AM. NE is what? NE plus CN is total. CE is equal to ME plus AM is AE. That is your proof of the first part. CE is equal to AE. Now when we talk in the second part, also we will use this only. Means it is given that NE is equal to ME, and it is given that CN is equal to AM, or we can say half of AB is equal to half of CD. Now in this case we can say half of AB can also be considered as ND, and half of AB can be considered as MB. Half of AB, this is AB, half of AB can be considered as MB. This is CD, half of CD can be considered as ND. So let us say this is equation number 3. Now we know that ND is equal to MB. This is equation number 1. This is equation number 3. Subtracting equation 3 from equation 1. So NE minus ND will be equal to ME minus MB. What we have done? Left hand side minus left hand side. So NE minus ND, NE minus ND. ME minus MB, ME minus MB. Now NE minus ND will give you DE. So in place of NE minus ND I can say DE, and similarly ME minus MB will be BE, and that is the proof of the second part. That is proved. This was the B is equal to DE you have to prove. So BE is equal to DE has been proved. So this is the working or solution of the last question that was in your exercise. Now I am ending with this question only, because we have a next topic, that is arc and chord properties of the circle. So that will be considered in the next class. So till then, you stay at home, stay blessed, keep on studying and study properly. So thank you all of you. Have a nice day. Stay blessed.